sum, difference, product, quotient of functions. All the formulas are pretty self-explanatory. So let's start looking at the first one. We have f plus g of x. So it is supposed to be f of x, right? Based on what you have seen in the past, f of x, but this time we change f of x to f plus g of x. So this is the sum of two functions. So f plus g of x is equals to f of x plus g of x. So all you have to do is you add the two functions together. For the minus, you subtract them. For the multiplication, you multiply them. For the division, you divide them. So this becomes a rational function. So since we have a denominator, you have to specify that the denominator can never be equal to 0. All right, so this can be used more than one functions, like let's say f plus g plus j of x. Yes, you can do that, and that becomes f of x plus g of x plus j of x if you add three functions together. So let's do some simple examples. We have f of x equals to 2x minus 1, and then the g of x is x squared minus 9. So let's do the plus. So we have f plus g of x, so that means you just add them. So that is a 2x plus, not 2x plus, 2x minus 1 plus x squared minus 9. So what is that equal to? That is equals to x squared, right? So x squared plus 2x, negative 1 minus 9, so that is a negative 10. So that is the sum of two functions. If you want to perform a function evaluation, we can do that. Let's stick with easy numbers. So let's say x equals to 0, then we have a 0 squared plus 2 times 0 minus 10. The result is equals to negative 10. That is for the function evaluation. Let's do a minus. So we have f minus g of x. So that is equals to f of x minus g of x, which is equals to 2x minus 1 minus x squared minus 9. That is 2x minus 1 minus x squared plus 9. And then you can just leave it like that. But I am sure that most of the book would like you to simplify this all the way to the end. So you have a negative x squared. Let's see, did I make a mistake? So negative x squared. All right, so you have a negative x squared. No, there's no mistake. And then plus 2x, 9 minus 1, that is a positive 8. For function evaluation, you can try f minus g. Let's put some easy number. Like let's don't try like negative 16 or those kind of numbers. Negative 1. So you have a negative 1 squared plus 2 times negative 1 plus 8. So that is equals to negative 1 minus 2, right? And then plus 8. So 8 minus 3 is equals to 5. There you go. And then the multiplication, so for the multiplication, let's don't move that all the way up. So you have f multiply g, right? So f multiply g, the dot means multiplication of x. So this is 2x minus 1. Oh, by the way, one thing that I need to emphasize is that when you subtract the g of x, do you see that? We just did this. Subtract the g of x. Make sure you use the parenthesis because you are subtracting the entire function. The parenthesis affects the distribution. So minus x minus 9 becomes a plus 9. Make sure you use a parenthesis for the minus. All right. This, you have a 2x minus 1 and then a x squared minus 9. So you are multiplying these two factors. So what do you have? 2x times x squared, 2x to the third, minus 2x times 9, minus x squared plus 9. All right, so we have a 2x to the third minus x squared minus 18x plus 9. And nothing else can be simplified. Let's do a function evaluation. I will just pick 1. 1 is easy, right? So 2 times 1 to the third minus 1 squared minus, why do I put an 18 in there? Did I make up 18x, right? 18x. So let's erase this. 18x. 18x. So negative 18 times 1 plus 9. So this is what? This is a 2 minus 1 minus 18 plus 9. So that is equals to negative 8, right? So we have a negative 9 minus 1, negative 10 plus 2 is negative 8. There we go. And then what else? What else? What else? We have a division, division. So f over g of x. So we have the f on top, 2x minus 1 divided by x squared minus 9. This one, what are some restrictions? Can you find the domain for me? So before let's just find the domain and then we do the function evaluation, because evaluation is easy, right? Just plug in a number. So what is the domain? Let's change this to a different color. What is the domain? For the domain, this is a rational function. Remember, denominator cannot equal to 0. Once again, denominator cannot equal to 0. Once again, denominator cannot equal to 0. So x squared minus 9 cannot be equal to 0. And then therefore, what is this? This is a x plus 3, right? And then x minus 3 cannot equal to 0. So x cannot be equal to negative 3 and pass the 3. All right, and then you draw a number line, take out the negative 3, take out the positive 3. What do I mean by take out? You use an open circle. That means x cannot be equal to these two numbers. So x can be anything else between them, anything else greater than positive 3, or anything else greater than negative 3. So the domain is from negative infinity to negative 3, from negative 3 to positive 3, and then from positive 3 to positive infinity. You can use a comma to separate the interval. So this one in inequality, this is x less than negative 3, x between negative 3 and positive 3, and x greater than negative 3. Function evaluation easy. So let's say f over g of what else do you want to put? Let's put a 2. We use 1 and negative 1, right? Let's do 2. So 2 times 2 minus 1, and then 2 squared minus 9. 4 minus 1 is 3. 4 minus 9 is negative 5, right? There you have it. Okay, that is not the end of this video, because I want to prepare another example for you. So that example is pretty interesting, especially in the division. So let me switch to a different color. Let's use orange. So this time I would like to let f of x equals to the square root of x squared minus 4, and then the g of x. Let's use a rational function, x squared divided by x plus 1. So f plus g, so you have f plus g of x, so that is equals to, you add them, right? The square root of x squared minus 4, and then plus x squared divided by x plus 1. So this one clearly, x cannot be equal to negative 1 for this, for the denominator. And then the minus, all you have to do is change the plus to a minus. You have the square root of x squared minus 4, subtract x squared divided by x plus 1. Again, x cannot be equal to negative 1. And then for a multiplication, f times g of x, that is equals to the square root of x squared minus 4. And then we multiply x squared divided by x plus 1. Let's put everything in the numerator. You can put the x squared on the back or on at the front. It doesn't matter. I prefer to put that at the front. X squared minus 4, and then this is a x plus 1. And then this, you have to also specify that x cannot be equal to negative 1. X cannot be equals to negative 1. And then look at the numerator. The numerator, do you see that there is a square root? You have to put x squared minus 4 greater than or equal to 0. You cannot have a negative inside. You cannot have a negative inside a square root. But what is x equals to, or let x greater than or equal to? I will answer that in the next question. All right, so this is pretty interesting. I will answer that in the next question. This is called nonlinear inequality. Again, nonlinear inequality. I will show you how to solve that. Okay, the next one is I want to do a g divided by f. Because I want to, you can try f divided by g. So you have a x squared divided by x plus 1, and then divided by the square root of x squared minus 4. So you definitely push the x plus 1 to the denominator. So you have x squared divided by x plus 1 in parentheses, and then you multiply x squared minus 4. And then, of course, that is not the end. We need to look for the domain. So we need to look for the domain. Let's just do that in a different color. For the domain, first of all, for this piece, we have to say x plus 1 cannot be equals to 0. So x cannot be equals to -1. And then the x squared minus 4 that is in the denominator. So we have to say x squared minus 4 just greater than 0, no equal, because once you have a 0, then the denominator is equals to 0. How do we solve a nonlinear inequality? Here is how. Factor x plus 2, x minus 2 greater than 0. Oh, please don't say, oh, using zero product property, we have x plus 2 greater than 0, x minus 2 greater than 0. That is wrong. All right, do not apply zero product property. That is for equal only. So this one we have to treat this x plus 2 times x minus 2 equals to 0, temporary. So x does not equals to -2 and positive 2. All right, and then you build a chart. So first we include this x plus 2, and then the second factor x minus 2, and then we draw a chart. And then all together we have a multiply, right? X plus 2 times x minus 2. And then the first x that we have to be aware is no -2, right? So no -2. And then the other one is no positive 2. No -2 and no positive 2. All right? And then this, we have to pick some number. So we have to pick x equals to 0. I'm not going to pick x equals to -1 because that is a restriction. And then this is a x equals to -3, x equals to positive 3, and then we plug in -3 plus 2, -3 minus 2, -5, that is equals to -1, 0 plus 2, 0 minus 2, -2, positive 2, 3 plus 2, 3 minus 2 equals to 1. Okay, do you see that this is a multiply? When you multiply these two, do you get a positive or negative? The answer is positive, and which is greater than 0. This is negative, less than 0. This is a positive, greater than 0. What are we looking for? We are looking for greater than 0. So that means we are taking this, and then we are taking this. So now let's sum everything into one interval. -2, positive 2, we have a -1. So this no -1, right? And then we want to take less than -2, and then we want to take a greater than 2. So what does that mean? That is from -infinity to -2, and then from 2 to positive infinity. So I just said cannot be equal to -1, which is fine, because if you take these two as, when you take these two interval as the domain, there is no -1. Okay, so that is x less than or equal to -2, x greater than or equal to positive 2. So that is your domain. Alright, so that is the end of this video. If you like the way I explain this, give me a like, give me a share, and a subscribe, and I will meet you all in the next video. Signing out.